Welcome to a City of Reading podcast. We have an exciting update this week as Reading will be known as the first city in California to complete an on-site 3D printed house. This is an innovative and creative project brought about by the City of Reading Housing Division and several community partners to help address the need for affordable housing in our area.
Today, we talk with Matthew Gile, the founder and chief visionary officer of Emergent 3D, the local construction company building a park host home in Enterprise Park with a massive 3D printing robot. Yes, a construction robot.
While other cities have constructed 3D printed houses from pieces printed in a factory, Reading will be the first city in California to 3D print a home on site. Matthew will detail what inspired this project, what construction looks like on a project of this kind, and why on-site 3D printing could be a game changer for affordable housing, not only here in Reading, but across the United States.
Another key player in this project is Access Homes, a local nonprofit organization that helps develop affordable housing options in our area. They were important to this first project and plan to use this model to continue to build affordable housing options in our community. We'll talk with Access Homes on another episode about how they plan to expand this program.
With that, get ready to have your mind blown on the creative and innovative possibilities 3D printing can bring to Reading.
My name is Matthew Gile. I'm the founder and chief visionary officer for Emergent 3D. And I've founded Emergent 3D in 2019. And really, it's kind of the proverbial out of the ashes. My wife and I and our family had moved to Reading actually 2 weeks before the car fire. And so it was a little bit of a rude introduction to the area. And I had been watching this technology for several years. And it actually started with the space industry where NASA was looking for ways to be able to print habitats autonomously either on the moon or on Mars. And so this 3D printing has been around for a very long time, since the 80s, but now it was in terms of construction scale, 3D printing is something that kind of the space industry helped accelerate. And we have a terrestrial housing issue. So we want to focus on the housing issue here. And so when I got hired on as the FEMA funded disaster case management program, the program manager with NDCSS here locally. And while being in the middle of our long-term recovery group, the recovery effort for the car fire, that's when I realized, and everybody was kind of scratching their head, how are we going to get recovered after this national disaster? And that's when Don and Jamie and I got introduced. He was heading up the construction committee for the long-term recovery group, and I was heading up the disaster case management committee. And through meeting twice a week, I realized, okay, it's either going to be mass automation or mass immigration that's going to help us address our severe shortage in the labor. And so with 3D printing, and it was now coming into a point where it was ready to be commercialized. I founded Emergent 3D to help address our car fire recovery effort.
That's great. Thank you, Matthew. Thank you so much for joining us today. I'm curious on the 3D printing technology as it relates to housing. How unique is that both here in California, but also in the States? And from what I understand, it's the more prevalent in other countries, but how unique is this technology here in the U.S.?
Europe and the Middle East is ahead of us quite significantly as regard to this technology and applying it to construction. And so they actually, the first European 3D printed building was, I think, back in 2017 or 2018 is when the very first one fully permitted was 3D printed there. And so that I have been watching this technology and was quite interested in it. So I actually took a trip to Europe to see who the top 3D printing manufacturers were. And we've had very few projects here in the United States that had been 3D printed. Some of the leaders like Icon and others, Icon I think was the first to have a fully permitted 3D printed house there in Austin, Texas. Since then, there's been more 3D printed projects completed in the United States, but there are a few other applications. There's 3D printing in a factory setting, like Mighty Buildings is doing an excellent job there out of Oakland. And then there's on-site 3D printing, like what we're doing. And it sounds a little bit like we're splitting hairs, but our 3D printer is set up on site and we print there on site. So now we're not printing components and then assembling. The project that we're doing here for the city of Reading will be the first on-site 3D printed house in the state of California. And so that's a huge milestone that we're really excited.
And Matthew, maybe you could just break down the process of 3D printing a little bit for somebody who is hearing this for the first time and they're like, how the heck do you 3D print a house?
Yeah.
What does that look like?
So just conceptually, the first time I stumbled upon it on YouTube, it blew my mind. And so if you can imagine or have seen a desktop 3D printer that prints toys or tools or those type of things, now just take that and scale it larger than a building. And so a giant 3D printing robot. And what it does is it layer upon layer, the smaller desktop 3D printers, they print in plastics or other substrates. We are actually printing in concrete. And so that is the technology has been around since the 80s, but it's just now being applied to the construction industry because of the material science, how to catch up. And so now that they've come up with a mix of concrete that can be 3D printable, that was the breakthrough that the material scientists came up with. And so it is assembled on site, the 3D printer. It's larger than the home itself. And then we attach it to our batch plant, into our pump with a special mix that goes into it. And we're batching our concrete right there on site, which is we're the second only in the States, United States, to receive this next generation printer that prints in concrete rather than a mortar. So that is also an evolution in how this technology goes. But it layers up the walls, just layer upon layer, and it does the perimeter. We're printing the exterior and interior walls, and it just layers the walls one layer at a time. And so the reason that we named Emergent 3D what we did is because it appears as though the walls are actually emerging from the ground as it prints.
That's fascinating technology. And so you mentioned concrete in lieu of mortar. What's the advantage of the concrete? Is it structurally stronger or quicker to adhere? Well, why concrete?
The biggest difference is the mortar wasn't code approved yet for the 3D printing application. And since we're able to print in conventional concrete that has what they call the secret sauce, the additive that goes into it that the mad scientists came up with the additive, this additive that goes into a locally sourced concrete to make it 3D printable. It secures our supply chain because then we can batch everything locally. So local gravel, sand, cement, and water just can be acquired, set up on site, and then done all there. We don't have lines of ready mix trucks coming. We just are scooping it right into our batch plant. That is a huge advantage. It's also a huge cost reduction.
I know there's a lot more that goes into building a 3D house than just the materials itself. Obviously, getting the printer out there and the crew that does have to do some things, especially we're talking electrical, plumbing, and other things that a home needs. What is the rough cost for a finished 3D printed home, both now and then what can you see it being in the future if this technology really scales and becomes a lot more prevalent?
We have to speak in terms of ratios because the material market is ever changing right now with our global supply chain the way it is. And so we feel comfortable saying that we're right now about 11% less than conventional methods of construction. That's overall cost of construction. This is before our team has their learning curve, so as our team become more efficient, then we'll be able to accelerate our print times, both for the setup of the machine and taking it down. So anywhere we can shave those hours off we pass that savings on to our customers. But additionally, because we have the next generation concrete printer, we have our structural engineer working right now for our next submission to the building department so that we can actually print the foundation and the slab as well. And so that will reduce the cost of putting up form boards, taking form boards down, and also the printer can do very unique shape that matches, the design of the house. And so that's where 3D printing shines is in the design palette. And so if we have curved walls, we can make it look like a lima bean or your favorite pickup truck, if you want. But to do that, to form that foundation and to match that shape would be very costly. We won't have to do that with our 3D printer. We can put a chalk line on it. It will do the outline, and then we can dig the footings to match that line, and then use our 3D printer as a glorified concrete pump. And then once we get up to grade, then we can start precision printing from there. And so we hope to push the savings to around 20%. That will probably be, in 2023 as we have several homes that we've already completed and our team has their efficiencies down. But we want to try to find every way that we can to utilize this technology to reduce the total cost of construction and shave off time of the construction schedule.
And I'm trying to visualize that process. I mean, obviously, I'm sure it's very complex, but essentially broken down, you're taking measurements and other renderings or whatnot from the computer and sending them to the printer, which then prints the exterior, interior walls, and as you mentioned, eventually possibly the foundation. And then once all the walls are up, then more traditional wiring come in, and then a traditional roof. So is the printer itself just printing the interior and exterior walls?
Presently, yes. That's correct. And so we will be using conventional wood trusses and then cabinets and doors and, plumbing and electrical. That's all going to be the same, though it's going to be slightly different. But we are going to be consulting with our, general contractors and subcontractors just to educate them on this. Just different enough. It's just slightly different, but the plumbing and electrical are inside the walls as normal. It's that we have a void that's within the wall, so we can run our plumbing and electrical. We're figuring out ways how we're going to be hanging our cabinets. That's going to be slightly different. So it's going to be a learning curve, but it's all of the things that our team is addressing. Our CEO is Donna Jamian is a builder of 37 years. And so with that expertise on the team, we're already addressing all those critical components that go into finishing out once the 3D printer is done doing its job.
I'm curious too, Matthew, you mentioned the void between the walls. On a traditional house, if you have, say, a plumbing leak on the pipes, you can punch through the drywall to access those pipes. On a concrete wall, what happens in that case?
If there's a catastrophic failure of the pipe, it's as nightmarish as you can imagine it might be with a concrete wall. But we are addressing that so that we don't have any splices within any of our plumbing in the wall. And so to mitigate that issue. Now, if we have a pipe that just catastrophically fails and breaks, then yes, we would have to cut into the wall, and it would be quite a job, to do that. But we have addressed that where we're end to end for our plumbing. There's not going to be cuts or splices for the plumbing, and then the same going for the electrical as well.
I do really want to get into the advantages and the disadvantages of 3D printing and homes, but for the purposes of today's conversation, I do want to bring up the Enterprise Park project and what's going on at Enterprise Park, and have you kind of walk through that project from your perspective. How did you get connected with the city of Reading and this project at Enterprise Park? Maybe you could just give us a little overview on what's happening there and why you're involved.
Yeah, absolutely. As being part of our community with our disaster recovery efforts, got to know many of the players, many of our community partners, both on the county side, the city side, our housing nonprofits, the other nonprofits, state and local. And so through those relationships, additionally, Dawn Jamian has been here in the North State, and specifically in Reading, 32 years. And so being a builder here for that long has those relationships as well. And so we asked for a meeting and said, hey, here's the technology that we're bringing. Is there any way that we can serve the city with any of the needs, not only disaster recovery, but for affordable housing, workforce housing, homelessness recovery? That's really the heartbeat of our company. As initially we founded it to address our initial disaster recovery effort, but we have a housing crisis. And so we wanted to broaden out the vision to be able to serve in every segment of the housing market. And so, but those are the most acute needs right now is within workforce, affordable housing, homelessness recovery, and disaster recovery. So just through meeting with city leadership and presenting what we were doing. And from there, they said, yes, we'd like to see if we can get behind you guys and if we can get through the code. And so by partnering with the planning department and which I think it probably at the end of the day was probably the most scrutinized set of plans in the North State in decades, because we said, just think you can be the first in the state of California. And city leadership was like, we want that. That would be great. We're for that because we want to bring housing solutions. And then the building officials like, oh no, we're going to be the first to have to approve a 3D printed house. And so we, through several rounds going back and forth between their 3 structural engineers and our 2, I think it was about 4 rounds of back and forth through the plan check process. But that gives us a lot of comfort that we know it's been absolutely scrutinized and fully vetted, to the last, period. That this is going to stand the test of time, and it's going to be a safe home.
And is the intention for this park host house to be a template of sorts, so that if this, this would be the first one that was built and constructed on site, would this exact house be a template for others that you will build in the city?
Currently, we'll do it up to 6 times for the City of Reading project. And so Enterprise Park, it would be location number 1, and then the Reginato boat ramp at Bonnie View and the Sacramento is going to be the park host home location number 2. And then have 4 other sites in partnership with Access Home and the city. They're off of St. Mark Street. And so, and that will go for housing for those in need for an at-risk population. And so we're really excited about that for the use case to serve those that most need in our community. And then we've also since then, this is a master plan approved. So within the city of Reading, but also then we took that same plan and got it master plan approved in Shasta County, Butte County, and the town of Paradise. And so we are working hard to move forward to get projects going in Paradise. And hopefully, as soon as this fall, we'll start our first, this same home that's going to be done in Enterprise Park, also in Paradise.
And do you have more designs that are coming through the pipeline as well? Or is this the same design that's going to be planned to print it, numerous times over? I'm just thinking of like in a traditional neighborhood, there's usually 3 or 4 styles of homes.
Yeah.
So they kind of scatter around. And just in terms of scalability, where can you see this going for not only Reading, but for other communities like Reading?
We have just released our architect to design 4 more floor plans ranging from 1,100 square feet to 1,900. So in that continuum there. So he's actively working on those, so that those are, the next models that we want to offer. We had our architect draw up 4 new designs that are just concept homes. And with that is to just think outside of the rectangle, so one of our homes is a circular home. It's I think around 3,200 square feet, but just it's totally round. And so that's where the 3D printing really shines is being able to do unique designs that would be totally cost prohibitive or nearly impossible to build conventionally. And so those ones, we'll see if we build those in the future, if there's interest, but just a dream on the type of things that this technology can deliver. And those are in the works, and you'll be seeing those very soon.
Matthew, you touched a little bit on some of the wildfire recovery efforts. I'm curious, for a 3D printed home, what type of fire resistance standards or wildfire mitigation standards are part of the construction? I know the city of Reading's looking at some building codes and other things to ensure that new homes are more resistant to wildfire. How do 3D printed homes come into play?
Yeah, thank you for that question. Obviously, coming out of the car fire, and that was our first home, is actually, we named it the Wildfire Restoration House. And so to serve our car fire recovery clients. And so it's concrete. And so concrete is fire resistant. We can't say when, nor would we ever say it's fireproof, but it's fire resistant. And then within the code, there is the wildland urban interface requirements, which is another list of code requirements in order to make it fire hardened. And so all of our designs, we've passed the code there. Not every area requires that, but we intend to make all of our homes wildland urban interface or WUI compliant regardless, so that families have peace of mind. Now, we can do flat roofs. We went with the nice normal aesthetic for the North State. So it is a wood truss roof, and there is wood on this. But if somebody wanted to have a 3D printed concrete roof to make it even more fire resistant, then we can design and do that as well. But in terms of it being highly fire resistant, that's what these 3D printed concrete homes are.
And I guess you could say that would be one of the advantages, right? Maybe you could talk through some of the other advantages of 3D printing home. Like, why is this technology a game changer?
On multiple fronts. I'll speak to the efficiency. The way that we design the wall system is we are printing a 2-inch exterior layer, then there's a 10-inch gap, and then another 2-inch interior layer. And so in that void, we're going to put blow-in insulation. Through our energy calc engineer, ran it through the models, and it calced out to be 29% more efficient than the 2020 code requires. And so in its worst orientation, north, south, east, and west. I haven't been able, just anecdotally, there's a home that was printed in Phoenix, Arizona. They're in Tempe by Habitat. And that family that moved in said they hadn't had to turn on the heater or air conditioner yet. Now, in its summertime, we'll see if that's actually holding to be true. Once we are finished and we have the data, I'm excited to see how efficient this home is going to be, but it hopefully will reduce the overall energy cost to heat or cool that house. Presently, our workforce and skilled workforce within construction, for every 5 that retire, there's only 1 that's coming in. And that's going to become more acute because the current generation that is the largest cohort started retiring about 2013. They're halfway through, and by 2030, the rest in that age group will retire. And then we only have 1 for every 5 going out. We only have 1 coming in. So that means that we're going to have an 80% shortfall in our construction labor. And so either it's going to be mass immigration or mass automation to plug that gap, massive shortfall. And by having a construction robot that is able to maximize our presently available workforce, it's a force multiplier that is going to be more and more needed every day as we go forward here. And so unless we are able to address the labor shortage, the prices for homes and building homes is still going to continue to rise. And so that's where it is a game changer. And 3D printing is just at the forefront. And there are other construction robotics that are coming, and we will be implementing those. And so as we have this, massive deficit of labor year on year, we're hoping that we'll be able to implement more and more construction robots to fill that gap, and then ultimately be able to be building homes on pace to meet the demand.
We covered many of the advantages of 3D printed homes. What about disadvantages? I'm assuming, you mentioned that it's a single printer, so that may, the scalability realm may be tougher, although it's a quicker build. So I guess, what do you see as, if any, as the disadvantages of 3D printed homes?
The aesthetic might be a concern. Like, is that a concrete wall? Is it going to be noisy? Those type of things. And we're working to address those. We're going to make sure with a custom, home builder on our team, the finishes are extremely important to us. And so we want to make these very livable homes. And so to mitigate, if you've seen a YouTube video of 3D printing, you can see the stratified look of the walls. Aesthetically, that may be a drawback, but we are going to be smoothing the walls if clients would like that. Some like the layered look, others would like a smooth wall. So we'll be able to address those. Maybe a drawback would be in the renovation arena. So we don't have to overuse the tool. So there are hybrids that are being built now. So for the rooms that you are looking to most likely are going to want to change, maybe in 10 to 15 years, maybe your bathroom or kitchen, we can conventionally frame those particular rooms so that you're not having to jackhammer down a wall or something. And so, but it's a new industry. And so the best practices are being learned now, and we'll implement those.
Seems like people just have to shift a little bit of their design perspective or the way they use the interior of the home. If these become more popular and prevalent and that it's the new way moving forward, it seems like it's just a kind of a mind shift in what you view of a home. But you might have touched on this before, but I'd like to get a really solid answer to this, because it feels like these are a lot quicker to build, but you do still have to take time for some of the more traditional electric and plumbing. So how long does it take from start to finish for the home? And then how much of that portion is the actual 3D printing process?
The limited amount of labor that we have, that's always going to be the bottleneck on any project. And so right now, for the home that we're going to be printing in Enterprise Park, it's a 3-bedroom, 2-bath, 1,200 square foot house. It calcs out that for the exterior and interior walls, we can print those in 31 and a half hours. So that, obviously, we're not going to do that, 24/7. We're going to split those over working days. And again, it takes about a day to set up the printer and a day to take it down. So once our teams are efficient, we anticipate to be able to print those walls and ultimately the foundation and slab very quickly. So right now, because of the global supply chain issues, it's just taking longer to get everything. And so before the pandemic, a home could be fully built in probably 4 to 5 months. Today, that's taking closer to 10 to 12 months. It's just waiting on those supplies to come in and materials. We are planning, hoping, and working towards trying to shave off about 20 to 30% of the construction schedule. We're not there yet because, again, this is going to be the first 3D printed, on-site 3D printed house in California. So there's that learning curve. But as we get more efficient, that's our intent. And however we can continue to reduce both the cost and the construction time, that's what we're actively working towards.
With regard to the machine or the printer itself, I'm guessing this is not an inexpensive piece of machinery. I think from what you said in the past, it was shipped from overseas on a boat. And so much of the 3D printing effort is reliant on this machine. What type of preventative maintenance do you have to do for it, or ongoing maintenance? And should something go awry with the machine, are there folks on your team or specialists here locally that can fix it, or do you have to get parts and pieces from overseas? How does that piece of it come into play?
Yeah, that's a wonderful question. That's been one of our biggest concerns. What should have taken about 6 weeks from Denmark to Reading actually ended up taking about 4.5 months because of every single port is apparently plugged up. And so we ended up ordering spare parts for anything that the manufacturer recommended that might go wrong so that we could have a spare set ready to go. We do have some of the top individuals on our team, top specialists within the 3D printing world. And so we just recently hired on one of the top in the industry, and we're excited to have him. He's our new CTO, and he does have expertise in that area. But if something were to malfunction or fail, we would have a challenge to get that fixed quickly. Though within our team, we do have that. The manufacturer that we bought from, Cobod, who's on the ground with our team right now, they're Enterprise Park, helping us, training our team and getting the printer set up. They just established their first U.S. headquarters in Florida. And so by next year, they're working towards having their manufacturing plant ready to go here in the United States. So that should shorten the time. And then they're also looking to multiply their manufacturing plants across the U.S. so that we can have that supply chain much closer to us. And so, but yes, they are expensive units, but it's as technology goes, they'll come down the technology cost curve. They'll become cheaper and cheaper as the years move forward.
And Matthew, as the Chief Visionary Officer, if you could wave a magic wand and project 5 years into the future and have it be exactly what you dream it would be, what does the future of 3D printing houses look like?
I have been watching this technology since 2016, 2017. And 3D printing is one of about 10 of what they call exponential technologies. Not every technology is an exponential technology, but it's technologies that grow in leaps and bounds from one year to the next, while also reducing their cost from year to year on a technology cost curve, because it's based upon Moore's law. And so because of that, we have seen that go from kind of a rudimentary printer in 2017 to becoming more and more sophisticated. To this company, Cobod had sold, I think in 2018, they had sold 1 or 2. Now fast forward to 2022 and they've sold 40 worldwide, and they continue to pick up steam. And significant players like GE now have invested into this company and are the top industry leaders, and their R&D are pouring into this. And so we're quickly going from a rudimentary 3D printer that prints in concrete to a construction robot. And so you're going to see there's other companies that are coming out that are wanting to put on attachments and, different things with a robotic arm. If you were to look at a Tesla factory and see all the robots in there that are building the most sophisticated cars, or some of the most sophisticated cars, and extrapolate that forward within the 3D printing industry, it's going to be hitting the J curve in sophistication, in capabilities, while coming down in cost. And so I anticipate a doubling effect year on year of this industry, and especially as more R&D money is being poured in, the best and brightest to make these construction robots that will do multiple other tasks. And so 5 years in the future, it's going to be very incredible, and we're going to see a sea change within the construction industry.
I'm curious too. I mean, you mentioned Tesla. I know when they first began producing and selling vehicles, they put some advanced technology in there, cameras and other things that maybe they weren't using at the time, but they knew down the road that would be technology that they'd like to incorporate into their computer systems or whatnot. Are there things in the 3D print world that you can do similar where, as you're saying, visionary piece, you maybe see down the road 5 or 10 years that the technology is not there yet, but you can proactively prepare some of these homes that you're building to adapt that technology down the road?
Absolutely. So we are wanting to be capturing every single data point that we can within our prints and on our technology. Data is what drives the innovation piece and informs that. And so we are proactively going to be adopting those things so that we can contribute on the innovation side as well. And that's is something that's attractive to many of the other industry leaders, is because we're doing the real world projects, that is where we're collecting all the data, and that allows for the iteration and innovation to happen. And so yes, we want to be at the forefront of all that as well.
I'm curious too on the strength of a 3D printed home. Obviously, concrete can be a very strong material. What is the lifespan for a 3D home, maybe compared to a traditionally built home? And what about here in the North State? Obviously, we're not immune to earthquakes. We talked about wildfire issues, but how does that come into play with regard to earthquakes, just general strength of the concrete?
So we were working, our team, structural engineer, our architect, and Don, our CEO, of getting through the California Building Code, which is probably some of the most difficult of all the 50 states. And one of those requirements is the seismic. And so through really just chipping away at that and trying to come up with a design through the code that addressed all of the codes, but specifically the seismic requirements. And so back in July of last year, with the City of Reading Building Department, we crossed that milestone, and that was a huge milestone for us. And so our designs, they meet all the seismic requirements for our specific area. There are, wherever we go, that have higher seismic requirements. We obviously will have to design to match that.
And is there anything else that you'd like to add to the conversation that maybe we haven't touched on today that you'd like people to know?
Yeah, I think the last part is there's hope within, even though we're having a massive labor shortage within the construction industry. Again, going back to that stat they shared, for every 5 going out, that there's 1 coming in. As we've been sharing with the 20-somethings, the 30-somethings that aren't as interested in construction, but very much, the digital natives of the world that are comfortable and like working with technology, when we share that they can print a home or a structure from their laptop, suddenly there's interest and the hands are going up. How do I get involved? And so that is extremely hopeful for us, and encouraging. And we have several of the 30-somethings and 20-somethings on our team now that came because they're interested in this technology. And so we're helping to create this new tech construction fusion. And so that is really exciting about this, that this is providing a way and interest to help us address our most acute need in the housing crisis. And so I see the future as very bright and hope-filled and beautiful because of what we can design and the interest that it's garnering.